about JupyterLab.
Thanks a lot, everyone, to be here. Uh, so, uh, uh, Currently, I'm working as a research associate at Cleveland Clinic, and during my day-to-day job, I just try to solve the problems that researcher working on biomedical data analysis encounter during their day-to-day job. So most of the time when you using a software or platform, it's not always sufficient that you can perform your entire analysis on a single software, but you have to in, incorporate different softwares and analysis method in your day-to-day work. So with this project, actually we try to solve the issues that we encountered during our research and we observed. So as my today's topic is about a JupyterLab extension that we have developed to connect two different platforms. So uh, uh, the first thing actually I want to talk about the issues actually. Uh, Most of the time, the biomedical informatic researcher experience during their day-to-day job. So the first thing is that the reproducibility. And I think that data reproducibility is the biggest issue. And sometimes it's due to the inconsistent data handling. Sometime when you are using a particular software or tool, the version differences also create an issue. Incomplete documentation also sometimes create issue in adopting any of the methods or algorithms in your research. And sometimes you got so many research publication, but when you try to access the available data and codes are not sufficiently shared, differences in the computational environment also create issue. So uh, this slide actually shows a standard scenario how a reproducible data science should looks like if somebody written a code. So at least if you are able to install the code, you should reproduce the entire analysis by your own. But in most of the cases, this is how the real scenario actually looks like. So apart from that, specifically when you talk about the biomedical data analysis, the inherently the field itself has its own challenges. When you talk about the volume of the data, uh, it it has huge amount uh, the data in terms of the size, and in terms of the variability, you are dealing with different image related data or the patient medical record. Uh, Apart from that, data also incorporates some kind of noise and quality related issue, and data itself very complex, and it required a certain kind of computational complexity to analyze it. Scalability is another issue when you try to analyze data on a different scales, so it's actually failed. So here I just want to give you an example of the next generation sequencing genomic data. So nowadays, if you want to detect a genetic variants, or if in case you are talking about any kind of disease diagnosis or treatment. The next generation sequencing data itself generate a huge volume of data. A single run can actually generate on an average 250 GB of the data. So in our lab, we are trying to solve these issues with a different software platform. One of the excellent platform is the Galaxy project. Galaxy project actually serving across 10 different servers and 7 different countries. Currently, we have around 360K active users, and we are processing almost 700K jobs per month. Apart from that, Galaxy is an open source browser-based application. You can easily create your account and you can use it, or if in case you have suitable infrastructure, you can install your own instances. It provided with more than 5,000 tools. So if you have your own instance, you can install it and you can easily use it. Apart from that, it has great resources for the beginner. If in case they want to adopt it, it's easy for them. If you want to use it, you can simply go to the usegalaxy.org, and if in case you want to install, you can directly install from our GitHub project. When you talk about the Galaxy web interface, so this is how actually it looks like. I just want to reshare my slides. Sorry for that. Yeah, Galaxy is a browser-based interface. As you can see at the website, you can access all the tools. While at the right side, you can access all the available data sets. Middle section actually shows a Galaxy tool from where you can actually run and execute jobs. And this is how a Galaxy workflow system looks like. So when you have certain kind of repetitive analysis, so with the tools, you can create a complex and reproducible workflow. These workflows actually ensure the reproducibility in terms of you can share your data and all the parameters that you use to perform your analysis. Different Galaxy servers actually serving a different user need. So I hope many of you guys heard about AlphaFold. So if you want, if in case you are working on the computational chemistry field, and if you want to use specifically tools designed for the computational chemistry, you can go to the use galaxy.eu and similar to that. Now I'm going to talk a limitation of Galaxy servers. So all tools are incredible, but they have certain kind of limitation. So you can't actually install all the tools on all the servers, and it's always impossible to have all the recent and advanced methods and algorithm available in the form of Galaxy tool. Sometimes it's difficult to share the data across the different Galaxy instances, so you have to manually download and upload your data. Apart from that, you can't actually intermix the tools that present on a different Galaxy servers. So now here it's come to the JupyterLab. So JupyterLab has some kind of capabilities that actually handle the issues that researcher actually face at the Galaxy side. So specifically, if we break down next generation sequencing data analysis, so it has two parts. Initially, when you got your raw reads and the raw data, so there are certain steps that you have to run repeatedly, and it involves the quality control and pre-processing step. But while you get your data matrices, so data comes to around 50 MB or sometime less than to it. But these data requires more interactive analysis, and it's not always depend on the tool. You have to rely on some kind of programming, and this is the place actually where your JupyterLab ID actually help you. In this project, what actually we try to do, we try to build a JupyterLab extension that actually bring the Galaxy and JupyterLab together and try to complement each other. So this is how actually a JupyterLab extension works. So you have a Galaxy instance running, and Galaxy provided with a BioBlend API. It's a Python-based API. You can access all the component of Galaxy as a JSON object. Then we implemented JupyterLab's extension recipe, and based on that, we can create all the Galaxy related from inside the JupyterLab, and we can access all the objects, specifically data objects and everything, to analyze the data interactively. Here I'm going to talk a little bit about how exactly the JupyterLab works. So JupyterLab is also a browser-based application, and it also rely based on a kernel side component and a front-end component. So kernel side component mainly handled by the Python kernel, while the backbone JS actually handle its MVC component. So when you execute a job through a JupyterLab cell, it actually activates a communication channel between kernel and the front end, and it sends a message, and that message actually encapsulate your code. And when the kernel executing that code, it runs the busy signal to the front end, and when the execution completed, front end actually sends back signals and data, and back end actually sends signal back to front end, and it executes your job. So JupyterLab extension actually built upon the same architecture. It actually composed of certain kind of widgets that execute inside the cell. It also implemented based on the IP widget library of the JupyterLab, and for the front-end component, it also rely on the backbone JS. So it's a simple workflow to create a JupyterLab extension. So if in case you want to build an extension, like first you have to define your backend component using the IP widget and a communication API which provide the communication between your front end and back end, and whatever other Python components that you want to create to execute job or process your data at the back end. While at the front end, mainly you use a backbone JS related component. You are defining your styles and DOM elements, and you uh, 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 prepare your entire package as a Node.js. Apart from that, you create a plugin .js file in which you put like all of your setting and configuration for your code. And then this entire package can be shipped as a Python package. So here I'm going to talk little bit about GiN. So like here, as you can see, we just try to so all the UI component that you are building at the backend, you inherit from the DOM widget class, which come from the IP widget, and here actually you are also defining your static component. So for example, what will be the name of your model and view, and this model and view component actually require to track the communication between the front end and the back end. Apart from that, you also define some kind of threadlet which actually handles your data and responsible to send your data as a JSON object from backend to front end. So here we define a Galaxy UI builder class, which actually interacting with a Galaxy based API and try to fetch all the components. The next step is you have to define a communication channel that actually pass messages between the front end and the back end. So here we define a tool manager which actually fetch all the tool JSON object from the Galaxy server, and we register a target. So the target is a function which is responsible to send a message across the front end and the back end, and then you register this target to communication channel. Uh, Apart from that, in case of the plugin.js, you are defining your extension detail. So it always required a unique ID. You also defining your activation logic, like at what time your extension is going to be activated when your JupyterLab server is starting. You also register the specific command with it if you want to activate certain commands when the JupyterLab is activating. If you so in case of the Galaxy, we have a specific menu where we populating our tools and everything. So here you can also define your tool and the other menu item. It also help us to provide all the configuration and setting inside your extension. So here inside our tool manager, we access the Galaxy session after the login, and one by one we are just trying to register all the Galaxy tool, and once actually all the Galaxy tools are registered, and as the kernel send the message to a front end that a tool sorry for that. So as the front end actually send a message to backend that a new tool had got registered, it automatically populates the tool menu, and based on that you can actually, as you log in through the Galaxy server through the JupyterLab, you can actually access all the tools which are actually available on the Galaxy server. So now you are actually accessing all the tools inside a JupyterLab notebook. And if we look at the backend perspective of a tool, so here is the Galaxy UI builder class looks like, where actually you are defining all the components of a tool. So for example, tool name, tool ID, tool description, and everything. And when this NB2 tool class executed inside the cell, it actually based on the tool ID, it requested API call to the Galaxy server, and based on that, it fetch all the JSON component and populates the tool. So the tool form, when a JSON component received by the backbone JS, so you can define your recipe which actually builds the DOM component for the JupyterLab widget. Yeah, so with this extension, actually, it helps us to minimize the troubles actually when we experiencing while we are using the different Galaxy instances. So on the same notebook, actually you can log into the different 3 or 4 Galaxy instances, and based on that you can also share the data across the different Galaxy instances. You don't need to download and re-upload the data. It ensures the reproducibility. Apart from that, you can actually intermix the tool which are available on the different Galaxy instances, but you can open all the tools on a JupyterLab, and you can save and share this JupyterLabs with all the parameters and the HTML form actually saved inside a notebook. And you can actually share this notebook if in case someone else want to reproduce your entire analysis. He can just simply, he don't need to set or change the parameter. He can just execute all the cell one by one, and he can reproduce your entire analysis with ease. So in conclusion, with the GiN, we just tried to solve some of the issues that we experience, specifically in terms of the reproducibility. with this, a user can actually interact with the multiple Galaxy instances within the notebook. User can fetch the Galaxy data object and if he want to perform any kind of analysis or programmatically, he can do it. And user can share and reproduce. User can share the reproducible data analysis notebooks. And the code is entirely open source. It's available on GitHub. You can also install it through pip install. And if you want to try it with the Docker, so we also build a Docker image. Thank you. And if in case you have any